Where should I stay? Here. All right, so thanks everyone for being in this room. I'm Sylvain Lebresne. I work for DataStax, and I work in the Cassandra team, so with Jonathan Ellis. And so my job is to work in Apache Cassandra. And for the past year or so, I've focused a good part of my time on CQL, the native protocol that Jonathan talked about this morning, and even some client-side stuff like the Java driver. I want the Java driver. So that's what I want to talk about today. So I want to, so what I will talk in this talk is that first I'll, briefly introduce the main idea behind CQL. So obviously I cannot go into all the details of CQL, and learning the two models in Cassandra require experience, and I cannot give you that in 40 minutes, but I get you the main idea between CQL and what makes it different from SQL, really. And then I'll focus a bit on the new thing that we've added in Cassandra 2.0 for CQL. Jonathan talked a bit about that too, so there'll be duplication there, but there's a few he hasn't talked about, so I'll go quickly over that. And then I want to talk a bit about the native protocol, also with the new things we've added in 2.0 and how that looked like from a client perspective. And well, we'll briefly talk about the ideas we have for the future. But really, so why did we do CQL in the first place? And the short version is that we wanted a better API for Cassandra. So Cassandra already had an API, which was called the Thrift API, because it used the Thrift framework. And we have nothing against the Thrift framework, but the Thrift API, as used by Cassandra, was not very satisfactory for a number of points we felt. The first and main one being that it's not very user-friendly. It's fairly hard to use, and in good part because it's a low-level API. There is very little abstraction. So what that means is that you'll do very basic stuff yourself, and every developer redo the same thing. So how do I store, multiple values and things like that? It's not really exposed well by a Thrift API. Or rather, you can do a lot of things, but you have to do it yourself. And there's many things that you don't want to redo all over again every time. So we wanted something with more tools to actually do development. And the other one is Thrift is kind of hard to evolve. A good part of it is the way we use Thrift in Cassandra. It's not necessarily Thrift in itself, but nonetheless, it was hard to add new features to Thrift without breaking backward compatibility. So we were adding stuff, but it was fairly ugly. And the last one, which actually I think matters quite a bit, is that the fact that Thrift, if you try to look at raw Thrift, or you insert something with Thrift, it's unreadable. It's like at least 5 lines just to insert one piece of data and one fairly dense 5 lines of code. So the result is that nobody using raw Thrift. Everybody is using a driver. But now, what is the API of Cassandra? It's dependent on the driver you're using. So it makes communication fairly hard. It's make it harder to talk about the API of Cassandra. And I think that's something that CQL really improved a lot. And that actually matters quite a bit. So at the end of the day, many people considered Cassandra being fairly hard to use from a development standpoint. And we believe that it doesn't have to be that way, that we could do better, but it was not just improving Thrift that would cut it. So we needed something kind of new. And CQL is our answer to that. So we believe it's fairly successful. It's an answer, and we believe it's a reasonable one. Now, very quickly, a first few historical notes is that the first version of CQL, which is called CQL 1, was introduced in 0.8. So it's kind of old for Cassandra. And in 1.0, it actually became CQL 2. We did a few changes that were breaking, but these are not the CQL version you are looking for, right? The version you are looking for is CQL 3, which I'll call CQL because that's really the only version I'll be talking about today, and the only version you should care about. And that version has been introduced in Cassandra 1.2, so at the beginning of this year, pretty much. And the reason I'm talking about the difference is that even though syntactically they may look a bit alike, even though there is difference syntactically too, but semantically, CQL 1 and 2 are much more closer from the Thrift API than they are of CQL in many ways. So even though the name look the same, CQL2, CQL3, CQL3 is a much different language. It's a more ambitious change from the Thrift API. So that's what I'll talk about, and I'll mention that CQL3 is the version that's here to stay. We don't plan on doing a CQL4 anytime soon. We're happy with CQL3. That's what we call it, just CQL. And we'll evolve it, and I'll talk about what we've already do from as evolution in Cassandra 2.0, but we'll evolve it, but in a backward compatible way, actually. All right, so let's get into what is CQL very quickly, at least. What are the main ideas behind CQL? So syntactically, CQL is really just a subset of SQL with a few extensions. There's extension areas there for specific to Cassandra, but it really looks like a subset of SQL. So you want to create a user table to have user profiles. You would do it that way. You will create a table. You'd have a user ID. We use UID in Cassandra, but that's because it's a distributed system. So doing auto increment doesn't work so well. So UID are a convenient solution to that, but it's kind of a details. You have an ID and then a number of properties here, and well, a user will be uniquely identified by his user ID. So it looks very SQL-ish. It's actually valid SQL. Actually, no, because UID is not a type of SQL, but that's kind of the details. And then you'll insert into that table exactly as you do in SQL. You use insert and update. One difference, though, to note is that the insert and update are both upserts. What I'm hearing here is that if you do an insert and the row exists, it will update it and it will complain. The same way if you do an update and the row doesn't exist, it will create the row. So that's a difference in semantic for the insert and the update. And I think that's the only difference where the semantic of the operation is different from SQL. We support a lot less stuff than SQL, but for what we support, when it looks like SQL, it behaves like SQL, except for that detail, that upsert. And there's technical reason, the fact that Cassandra doesn't do read before writes, that force us to do that. Now, we still advise to use insert when you actually mean insert, and updates when you actually mean update in your code. Even though the database doesn't validate it, it's a good documentation, so that's why we support both of them. But they are kind of the same operation in practice. But as I said, there's a number of things we don't support. We don't have join, we don't have subqueries, we don't have aggregation, and we have limited order by. So on the query side of things, it's really not SQL, right? So CQL really differs from SQL, how you query things, and because of that, it differs a lot how you actually will model things. And the way you do it in Cassandra is you use denormalization. So CQL is a kind of denormalized SQL. It's an SQL where you actually will use denormalization as your main tool for modeling your data model. The idea here is that you want to do work at write time. So Cassandra is fast at writing, so you will write more. But you will write data so that reading it is easy, all right? That you want to group them at write time the way you will query it. That's really the idea. So staying on that denormalization a bit, because that's the important difference in Cassandra compared to RDBMS as far as modeling goes. Why do we denormalize? Well, the goals here to have efficient queries is Cassandra is that you want a query to reach only one node, or actually a replica set, because we have replication, and depending on the consistency, we may have to hit one or more replica. But you still want to, you don't want to contact many nodes, a random number of nodes in your cluster, pull data on one coordinator, do some join. You don't want to do that because that won't be efficient. So the idea is that you will group data that is that will be queried together on the node. And when you do that, you also want to actually collocate data on disk. That is not only you will put data that you query together on one node, but you will actually write it sequentially on disk. And well, that's the way Cassandra works. It's the way the storage engine works. It stores data sorted on disk, and you want to use that because if you use that, then a query just reads a sequential amount of data on one disk on one machine. I mean, it's a little bit more complicated in practice. There is replication and whatnot, but that's the basic idea of what you want to achieve here. And the denormalization is a technique that allows to achieve that. It's by duplicating data, grouping it together, that you're able to achieve that on the read side. So you want to do denormalization. Now, I'm not saying denormalization is easy. You have to learn how to do it well, what to denormalize, how much to denormalize, when to denormalize. So that's part of learning how to model into Cassandra, and you will have to learn that by going to the online training that DataStax put on today and other resources. But nonetheless, that's what you should focus on, denormalizing. Now, back to CQL, what that means is that CQL, the important part of CQL is exposing how you collocate your data on a replica set. And the other thing is that how you collocate data on disk, right? Because that's how you get efficient queries. So you need to have tools in CQL to do that. And the tool to do that in CQL is really the primary key. So the primary key in CQL has additional meanings compared to the one it has in SQL. It is a primary key in the SQL sense of the way. It identifies uniquely rows in a table, but there is additional meanings. So to see that, so let's use a simple example where you want to store inboxes for users. So you want for all your users have their inboxes of email. So you'll start that, for example, by having a table inboxes. An inbox will have a user ID. That's the inbox of this user. And then for each user, you have a number of emails that composes his inbox, right? So you have an email ID. And then you denormalize a number of things about the email. What you denormalize is largely application dependent, but in my example, I said that I want to have a sender, a recipient, that I can have more than one recipient, so it's a set. Then I have a subject of the email, and maybe I'll keep whether or not this email has been read because I want to show it the same way to the user. Okay? And the primary key is the user ID and the email ID because it uniquely identifies an email in an inbox. Okay? Now, as I said, the actual choice that you made here of component as a primary key actually matter quite a lot in CQL because the first element of the primary key, so here it's user ID, is what we call the partition key in CQL. The partition key is what defines on which nodes the row go. More precisely, the guarantee that CQL will give you is that all the rows that have the same partition key will be stored in the same replica set. So that's by picking this partition key that you will know, or you will choose that partition key so that you collocate on nodes the data you will query together. In that case, I want to put all the email for one user on one node because I will query that inbox. The user login, I want to show his inbox, so I need all his mail. So I will put it all in one node. But the different user inbox may be completely distributed over my node. So I will still scale because I'm able to have billions of users, but for one user, I want it all on one box. Then the second part of first remark is that every table in CQL needs to have a primary key, and a primary key has at least one component. So there is always a partition key. Okay, so you always have a partition key. Sometimes the partition key is the same thing that the primary key because you have only one component in your primary key. But in that case, that's not so it's not the case here. You have a second component that's the email ID, and that's what we call the clustering column. So actually, you can have more components if you want, if you need to in the primary key. So you can have more than one clustering columns. But what the clustering columns do is that within a partition, so for the same partition key, they tell you how data is sorted on disk. Okay? So in that case, what it means is that for a given user, all his email, all his inbox email will be sorted following the email ID. And the email ID is a time UID. So time UID is a unique ID of the email, but that's a time component, typically the time where the email was sent, okay? Or maybe received, but that's probably the same thing. So in that case, the reason I use email ID as the clustering column is that I want my email for users sorted chronologically, okay? And that's what this primary key definition gives me. Now that matters quite a lot in CQL because the primary key defines what query you actually can do. Remember that you won't join and subquery, so you can really query things following the primary key. in that case, what that parameter gives me is that I can get, for example, the 50 last emails of a user inbox. And I can do that because all the email for that user will be on one box, and then they are already sorted by email ID on disk anyway. So that query will be very fast. Okay, the guarantee is that this query will be fast. There's no planning or anything going on. We read some part of the disk on one box. And you could do things like give me the email between two dates, because again, the email ID, the emails are stored chronologically, so you're able to do that. All right, so that's kind of the main principle of CQL, really. The rest is experience, how you actually model, but that's really the main, the big principle behind CQL. Now, we have a few features that helps you actually model things. For example, we support collection. I had an example with my recipients. So we support set, maps, and actual lists. I'll note that the list have a few performance gotcha. So if you can, so the general advice is use a set if you really don't need a list, and use a list only if you really need it. But know that there is some operation of the list, like setting an element by index, require a read before a write, so it will be slower than other operations. So you have to be aware of that. The other feature that was is the secondary indexes. So I said before that you can query things based on the primary key, but you can actually create secondary indexes that you can use to query. So that's convenient. But do note that even though they are convenient, they have performances characteristic that doesn't always will work for your use case. So it's very common to, instead of using a secondary indexes, to actually create an inbox like I've done, for example. Okay, and we have a number of convenience things, really. So we have a few convenience functions. We have a few things to work with time UID, extract the date, or work with them, and we have type conversion. So, you know, a lot of things that we couldn't do with Thrift, but we can do with CQL, so we give them as convenience. Now, if you want more detail on CQL, there's a number of docs here that you should say. But I want to call out the more recent addition we did in CQL. So I want to talk about the features that are new in Cassandra 2.0 on the CQL front. So what did we added to that languages in 2.0? Well, the first one is, well, we have support for the lightweight transaction that Jonathan talked about in the keynote. So I won't go back into how this works, just that the syntax is the if here. So for insert and update, you can have a if. That's basically for the update that gives you a compared swap that's guaranteed to be atomic. And for the insert, it guarantees you that only one thread will ever create that row here. So again, there's performances. The performances of using if. I mean, there's a drawback in performances. There's a number of round trip that you have to do some queries. So be careful with that. Don't use them all the time, but they exist. The other one is trigger. From the CQL standpoint, there isn't much except a new syntax to declare trigger, but that's all there is. The rest, you should see Jonathan's keynote. And triggers are experimental anyway, so I'll mention them. The other one is more interesting, is the ability to drop. So if you have a table like that with a number of property, in 1.2 you cannot drop that a column of that table, and you can in 2.0. And when you do that, what really happens is we just register some metadata that says drop, and the actual deletion of the data is done by compaction. Like everything in Cassandra, we do deletion during the compaction. I'll note that you can force the deletion if you want. You can actually use not-tool upgrade SS table, which is a command that will rewrite all the SS table, and it will remove all the data right away if you want to, but you can just wait for things to go out automatically with compaction if you're not in a hurry. The other thing that we added is the ability to use prepared variable for the timestamp, the TTL, and the limit that are things that are the extension I was talking about on CQL. We support TTL. Well, the limit is actually SQL, but the timestamp is the timestamp we use for a reconciling operation. So anyway, in 1.2 you were not able to use prepared variable there. That was a limitation. We've lifted it in 2.0. Another one is conditional DDL, so that's just a convenience so that if the table exists, then this request won't return an error. It would just say that's fine. So that's just vaguely convenient. The other one is the ability to use, to create secondary indexes on more type of columns. More precisely, in 1.2, you weren't able to create that kind of secondary indexes because creating that is part of a primary key. So the limitation in 1.2 is no secondary indexes on primary key columns. In 2.0, you actually can. So you can you can create indexes. I'm not saying that this one particularly makes sense, by the way, but you can create indexes on primary key columns. There's an almost here because there's still one limitation, which is the collection. We can still not create secondary indexes on collections, and that's coming, but it's not done yet. And the last one, which is kind of another convenience, which is the aliases. So we don't have join or subqueries. So the aliases are probably less useful than they are in SQL. But nonetheless, when you use function calls in the selection, then it allows to give a shorter name that you can use in your driver to get back the data if you want. Now, there's a few features that I want to talk about. There's 3 features that actually didn't make it in Cassandra 2.0, but that will be added in Cassandra 2.0.2. So 2.0.2 is not released yet. It will be hopefully at the end of next week, and hopefully no later than the beginning of the week after that. So it's the next version that is coming, and what we've added there is first the ability to have name bind variables. So you can use a question marks to have a bind variable, but in 2.0.2 you can also have named ones. So tilo, ti, and k. There's a k there. Anyway, so tilo and ti here are 2 name bind variables. So you use a column and the name. And well, the reason you want to do that is because in your driver you can use those names to actually bind values to the variable. So it's a convenience. The other one is the ability to put a prepared statement with the in. That wasn't possible before, so it's fixed in 2.0.2. And the last one is the limited select distinct that Jonathan also mentioned in his keynote. It's very limited because the only version we support is select distinct on the partition key. So if you use distinct, the only thing allowed here is the partition key. So basically what this is about, it's about listing the partition key that you're using. But sometimes it's useful for a number of tasks, and it happens that internally we actually have indexes on the partition key, so we're able to respond to that query with just using those indexes. So one of the reasons we actually have a special syntax for that is that we can do that reasonably efficiently. That doesn't mean that we won't eat disk because the index I'm talking about are on disk, but that does mean that we don't go see the data file. Does that answer the question?
I just wanted to know if there's support for paging for that one, because the indexes might be huge. Right?
Yes, so I will talk about the paging, and it's orthogonal to that, in a way. So all right, so we support that. So that's it for the SQL parts. So as you can see, we're adding conveniences and things that we're missing for the first version, basically, now. Now I want to talk a bit about the native protocol because I think that's kind of an integral part of SQL. So with the addition of a CQL, or really CQL3, but again, that's the only CQL that matters, we've added the binary, what we call the native protocol, and that's really a binary transport protocol for SQL. So what this protocol does is just define how you do query execution, so how you actually send the query string to the server, and of course it supports prepared statement and the execution of prepared statement. It supports authentication. We have compression. We actually support SSL, even though that's not really part of the protocol. But the usual things. It has a few characteristics too that's you can call out, like the fact that it's asynchronous. What that means here is that you can actually send multiple queries, pipeline multiple queries on the same connection without having to wait for the response to the first query. So the good thing about that is that it allows you to work with less connection to the server. And particularly matter when you have large clusters with a large number of clients, then the number of connection can really start to be a problem, and it addressed that problem. The other thing that we have is that protocol is server notification. So the type of notification we have here so far is a new node joined the cluster, and the server send a notification to the clients. Or there's been a change to the schema, or a node died, things like that. So some driver allows you to actually listen to those events, but the main reason they exist is for the driver themselves. So the goal is that it allows to write drivers that are more reactive, that don't have to pull the state of the cluster all the time. If a new node join, I receive the notification, I'm able to add it to my pool of connection and use it efficiently, right? Now, of course, as an end user, you won't really use the protocol unless you want to write a driver. What you will use is a driver, and we already have a few existing drivers for that protocol. The two first ones, Java and C#, are actually stable, ready for production. The Python is beta, and there's other drivers for other languages in different state of development. I know them a little bit less, but things are moving fast on that front. Now, I'll use the Java driver for a few examples because that's the one I know. But basically, how that looks like, if you want to do a query with the Java driver, you will connect to your cluster by creating a cluster object. So you need just a contact point. So that's just the address to one of the node. You only need one because the cluster will discover the rest of the cluster by himself. It just needs to be able to talk to at least one node. But then you have this cluster, and then you connect to a key space that gives you a session object. And in the driver, the session object is really an object that abstracts from you the fact that there is a whole cluster behind the session object. So it abstracts you will use the session. It's a thread set object. You will have only one session for the whole application. You will use it in all of your thread, and it will dispatch the query. It will load balance the query correctly. It will do failover if a node fails while you're doing query, so you don't have to care about it. It will use another node automatically, and a lot more. And there's you can actually configure the behavior of all those things, but that's configuration that you can put on the builder here. But when you have a session, then you just use this to do query, and you don't care about the rest. So you typically execute you typically select the data from your table that give you rows, and you do something with them. That's kind of the spirit of the driver. Now, in Cassandra 2.0, we actually introduced a second version of that native protocol. There was a number of features that weren't ready for 1.2, so we still released the first version of the protocol, but we added those features in Cassandra 2.0. So it's a separate version of the native protocol. You need a driver that actually speaks the version 2 of the protocol, but I'll still note that Cassandra 2.0 speaks both versions of the protocol. It still speaks the first version. So the driver that works again 1.2 will work again 2.0. But if you want to use the new feature I'll talk about, you need a driver that speaks the version 2. So for example, the Java driver has a version that speaks version 2. And the new feature that you have thanks to that new protocol version is, the first one is cursor. So the goal of cursor is to make that query work. That thing here, that query here, doesn't work in 1.2 or with the first version of a protocol, because if you do that, the protocol will try to fetch everything that matches this. And except if you have a very small table, if you have a real table with a lot of data, we won't be able to do that within the timeout of Cassandra, and really will probably OM the server. So in 1.2, you're not supposed to do that. You're supposed to page things yourself. And as Jonathan showed in the keynote this morning, that's painful. So really, with now with version 2 of the protocol, that's handled by the protocol. You don't have to care. So you can do that, and it will fetch data automatically, incrementally. The other feature we've added is the ability to batch prepared statement. So you can prepare an insert. So okay, I've resized my slide. So here there's number of bind variables for the values, and then I can bind in a few times and put everything in a batch statement and execute that. So I really execute only one query, but that batch 3 other queries. So I wasn't able to do that in 1.2. To be precise, in 1.2 I was able to prepare a batch statement, but that requires you to know exactly how many queries there will be in the batch, and that's not as convenient. So that's a lot more convenient. The last kind of user visible feature we've added in the protocol is the ability to send a query with variables and the value alongside. So in general, when you actually have bind variables, you want to prepare the query because you will use them repeatedly. So you want to save the parsing of that query, right? But there's a few cases where you actually will execute the query only once. So you don't want to prepare the query and then execute because you'll do 2 round trip to the server, and that's useless. But you still don't want to serialize everything to a string because maybe here that's supposed to say photo bytes. So maybe you have a blob here that you want to insert. And if you actually serialize the blob into a string, that's inefficient. You will use X encoding as that's inefficient. So the idea here is you can now do that by sending directly both the queries variable and the values, and you do only 1 round trip. And then the last kind of features is that we actually use SSL for authentication. So the first version of the protocol had authentication, but it was kind of ad hoc, and it was okay for simple authentication scheme, but wasn't really working for serious authentication stuff. So we know support SSL, which is a standard, so it's better, basically. So that's the state of the native protocol where we are today. So what do we want to do next? So which idea do we have? So on the native protocol things, we're fairly happy with the feature that we have. We'll probably have a new version of the protocol because sometimes new feature that we have needs some protocol support. But we don't have big things for the protocol. We're fairly happy, except for working on the performances. We'll try to improve performances, but on the feature side, we're happy. But on CQL, well, we have a few ideas that we want to work on. Well, the first one is, under the hood, we probably want to do a few storage engine optimization. The fact is, we know our CQL layout is data on the storage engine, so we could use that knowledge to actually do specific optimization for that. And I'd like to do a few of them at some point. And the other one is the secondary indexes for collection. As I said, that's the one thing that is missing, so we want to add that, probably in 2.1. So I'm not saying all of those will be in 2.1, but probably at least the secondary indexes for collection will be, and the user-defined type will be. But there's also, we've talked about adding server-side functions, so possibly aggregation function that executes server-side. We're not exactly sure how we want to do it. There's a number of open questions, but there's interest there, so we'll probably support some form of it at some point, but probably not for 2.1, to be honest. So we have a feature, but one feature that I want to show you an example of is user-defined types, and actually I think Jonathan showed the same example this morning, but that one will be in 2.1 because the patch is pretty much coded. It's not committed, but it's pretty much written. And I think it's a fairly nice feature, and the goal here is to be able to do that definition where you create a type address that have the few things that you want to have in an address. I'll note that you can have actually collection in there, so through that you will have some form of collection nesting. And when you have this address, you can create your table user that have user profile. The user will have an ID, maybe a name, but it will have a number of addresses. So you will have a work address, gnome address, and whatnot. So the addresses will be a map with the name of the address, so for example, work, and then you will have a value of that type address. So the way we insert that, so you insert a new user, and maybe you update the addresses by adding a work address, and then the syntax will probably look like that. Again, it's not it's coming, so the syntax may change, but it will likely look like that. So you're able to do that. What I want to note here is that this is really creating a value, right? So in particular, you won't be able to update just the street of the work address. If you want to update an address, you will have to change it all. So internally, this is really the same thing that if you were writing blob here and you were serializing all of that manually into that blob. That's really the way it works. But, well, it's a pretty nice syntax to do that. So then again, we're here to give you tools that make it easy to work with SQL. So we think it will be pretty useful. And that's all I have. If you have a full question, we may have 1 or 2 minutes or something for question, and I'll be there. Question at the end?
I have actually 3 questions. Sorry for it. So the first would be that, are you planning to support the select in statements for secondary indexes?
Okay, I'll do one at a time because my memory is not that good. So the first question was, will you support the in for secondary indexes? I don't know. We haven't worked on it. Is there a problem doing that? That's probably doable. The fact is secondary indexes are often not that efficient, so we're trying to improve them first, and we'll see. Yeah, we may support it, but I cannot say that it's on the to-do list. There's a number of improvements like that we will do them, but we try to do them in the order of the more important, what we consider as more important, and that's probably not, it's not that important. The reason is that if you actually do multiple queries, it won't be really that much inefficient. So if we support it server-side, we won't really be able to do it much more efficiently than just doing the query one after the other. The only optimization we can do is parallelize, but it's pretty easy to parallelize a client-side, especially with the Java driver that do things asynchronously. So the reason is that it's not that useful, but we might support it nonetheless. What is it? Maybe 7 questions?
Yeah, second question is regarding DD. So
Sorry?
how efficient they are, and how much they are degrading the performance regarding when you make delete for complete rows, or you delete columns only.
So you're asking about the difference of deleting a rows versus deleting a column.
Yeah, and overall how much they affect performance, because of this tombstone.
Okay. The answer is so when you delete a row, it actually inserts a tombstone, but that's a range tombstone. So instead of inserting just a tombstone that say this name is deleted, basically, it's a all those names are deleted, all the names between, because things are sorted on disk, we can do a range, and we say we delete all of that. So in terms of storage, for example, there isn't much difference. It doesn't change much. If you have a lot of range tombstone, well, we use in the early version of 1.2, and when I say early version, I think up until 1.7 or something, maybe at 1.8, the range tombstone were pretty inefficient due to bad implementation. Nowadays, there shouldn't be a big difference. But there is if you do a lot of tombstone, you will have problem with performances because the reads have to skip them. But there isn't much difference between a row tombstone and a column tombstone, is what I'm saying, at least with recent version of Cassandra. There used to be a big one, but that was a bug, I'd say. Maybe someone else, and I can answer then after talk test. Yeah.
Yes, my question is about the user-defined types
Yeah.
and putting them in collections.
Yeah.
With the current, for example, set of simple values like text,
Yeah.
my understanding is that the text values go into the column names
That's true.
in the storage engine.
That's true.
My question for the user-defined types will those more complex
No.
objects go
The answer
into
is no. The answer is it will go into the column name. So yeah, what I didn't say is that the collection are really meant for staying fairly small. The goal is to denormalize small type of value. The small test is if you know that you will need to slice your collection, then you probably need a separate table because that's where you actually are able to do slicing properly. So you need something that's small and that can be read at once. And that will be true for the user-defined user type because there will be one value, so they have that same kind of limitation. Sorry. So they will be they will be stored inside the column name.
They still will be.
They will be,
As
yes.
blobs.
As a blob. There are blobs. I mean, so to be precise, the good thing about user types is that if you want to use them in 2.0, you can just use a composite type as the value of your column, which you can do. It looks awfully, but you use a string as the name, and you could actually use the underlying composite type. And that's exactly what we're using. So it's a blob that's used the format of the composite type. So if you use composite type for your value today, you will be able to switch to the user type if you want. Okay. What, last question? That's what you're saying?
Okay, last question would be that are you planning to support something like paging, but in a way that you can like jump right away to like page 5 or something like that?
Okay.
Or is it something for what we have to put the search engine on top of?
So the question is, we have paging, but is there a way to implement it, to implement actual page, like go to page 5? And the answer is no. And the longer answer is we don't know how to do that efficiently, because well, there's many obstacles to that. One of it being that because we're distributed, we are not even sure that we always have all the results in one box. So it makes it hard to just say here maintain the pages is hard. So you have to do it with a search engine or something, or you have to do it yourself. Basically, we don't know how to do it very efficiently, so you have to do it. You can probably do it in your special use case, but doing it in general is hard, and we don't know how to do it. If you have an ID, please open a ticket, and we'll be happy to look at it, but we don't know. And I think that's it.
Yeah.
Thank you.
Power plug.
Sorry?
You can't find a power plug.